Hi, I'm Everett. Welcome back to the shop. One other machining task I have to do on that Volvo that we had in the shop, which we had to replace injectors and injector sleeves on. And that's the one I had to make the tool for to pull the injectors, the injector cups or injector sleeves as they're sometimes called. One of the other things is the valve cover needs some repair as well. There's a ventilation tube that comes off the top of the valve cover on the side, and there's kind of a bad design factor on this one because of the fact that they put these inserts in where they're just perfect to collect moisture and corrode onto the bolts, and they snapped right off. Now, yes, you can get used valve covers or even new ones, but used ones are some in the neighborhood of 200 US and new ones are in the neighborhood of 500 from what I can tell looking them up. And we're trying to keep the costs reasonable for this fella. He's actually a friend of ours. So anyway, in this video what we're going to do is we'll do some unconventional setups, and hopefully it'll hopefully not too sketchy, and hopefully we'll be able to extract these without destroying the valve cover. So hope you find it interesting. So as I say, maybe there are other ways this could have been done. Maybe this was just the cheapest way they could. I really don't think much of this design of theirs. These metal inserts here slide into a channel into the cast plastic valve cover. There are these torque limiters which are cast into the valve cover. However, the bolts go through these torque limiters into these little blocks threaded in there. My buddy Taylor at work, he was able to get this one here drilled up most of the way, and it just won't quite move that insert. Now, one of the issues with that too is we don't know how far the bolt goes through. So what I want to do first off is I want to have some way of grabbing onto these. For that, what I'm going to do is I'm going to set up here, and we're going to drill and tap number 832 screw hole or screw thread into either, a hole in each. That gives something I can put a screw in to use as a handle to try working it out once I get the screw out or the bolts out. So we're going to set up first for that and drill and tap these. I do have to do a bit of interesting setup for that though. So in looking in the engineer's black book here, I know I could look it up in Machinery's handbook, but this is much quicker. Thanks again, Eldon. I do appreciate you giving me this copy. It's saying that a number 832 screw uses a number 29 drill bit for its tap drill. I have a plug tap and then a bottoming tap here. And here's my number 832 screw. The thing is, it's onto a slanted surface on both sides. So what I'm going to do is I'm going to use an end mill here to just create a little flat spot. Once I create that little flat spot, then I'm going to then we're going to drill it and tap it. So I realize that I have a drill chuck in here and I'm going to use an end mill. I'm just going to use it to make the flat spot. I don't normally do milling with a drill chuck. Now I have the valve cover clamped to the table with two bolts, well, two of the T-bolts. The holes in the valve cover itself are big enough to let the studs pass through, so this is the easy setup of the two setups we're going to need. One of the first things I'm going to do is get a quill wheel on this thing. Kind of missed that from my old mill drill. No, I'm not saying that because I can make money off it, because I don't. I just think Jim's cool. And we're just going to eyeball it. I'm going to go to the thickest part of the... I want to go to the thickest part of it. You can even see the insert moving. All right. The trick is I'm trying to do this very carefully so I don't break the valve cover. That should be deep enough. There. Now, there's no way I'm power tapping this. And sadly, my drill chuck tap handle, come on, there we go. Yeah, there. Sadly, I don't have a drill chuck tap handle to fit this. Last one I had went with my buddy Eldon when he bought the mill drill. Bunch of gear I need to make for this thing yet. Thankfully, this is a small thread. There, that started. Yeah, hits me every time. Sadly, my air compressor's on the fritz right now, so I can't use the air blower. Got to repair a bunch of lines. So that was the plug tap, or well, it'll be the middle tap in a set. But I've only got a set that has the middle tap and bottoming tap. Here in Canada, the intermediate one's called the plug tap. Right now I'm using the bottoming to bring down my threads a little bit further. There we go, we're done. Again, it only needs a few threads, so I can snug that down a little further with a screwdriver. When I get that, well, when I get this thing cut out, then I got something with which to pull to get that insert out. So I'm going to do the same thing on this side. It's more the same. You probably don't want to watch me repeat myself, so I'll bring you back in at the next step. So like my buddy Dan says, he says, if it looks stupid but works, it's not stupid. Now, in reality, because this thing's plastic to start with, and I mean it's not the strongest piece to begin with, trying to clamp it down to anything, even if I had a massive angle plate, it's not going to work. So what I've done is I've said, just so happen to have this piece of OSB in my scrap pile, and ironically, it's within a 1/16 of an inch or so, just a millimeter or so of the outside edges of the valve cover. So I basically zapped a bunch of screws into each of the angle plates there, one here, one down the other end, and clamped it down. What I'm going to do is now I need a brace to go from this nut here down to the table so we can triangulate it, because it's not bad now, but if we triangulate it, it'll be much better. And like my buddy Dan was saying, it ain't stupid if it looks stupid but works. So anyway, this is actually fairly rigid now. It's going to be rigid enough to drill a couple holes. Like I say, I'm drilling, not doing milling with side load or whatever, so this is as good as I can make it. I don't really have room for the drill chuck, so I'm going to have to use collets. But yeah, I'll get set up on centered. I'm probably going to start on the on this one here first. It's got a little bit of looseness to it already. But the basic point here is I want to get through it with a 1/4 inch end mill and then see if that'll let it loose. I have a suspicion that the bolt has gone through that that little boss, if you will. So we'll see. Well, I think it got through. Now, will you come out? Nope. 266 or letter H drill bit is the tap drill for M8. Basically, we just need to get a bolt in there one way or the other, so even if I just have to tap it in situ, that is not the end of the world. There. Alright, here's hoping this is actually making a clean thread, not just making a nasty hole. Well, to be honest, it sounds kind of crunchy, but see how it works. Alright, well, here's an M8 by 1.25 bolt. There. You know, yeah, for what it needs to do, that will hold. Like I say, it's only got to hold it's only holding a vent tube on this side, so I guess we didn't need to drill them. Oh well, live and learn. Right, on to the next one. Like I say, as long as I have some sort of functional thread in here, because it's not like it's a cat head bolt or something. Well, this is basically as far as I needed to get. It's certainly not the prettiest, well, threaded hole repair or bolt, well, I didn't even extract the bolt. These two holes, turns out, weren't necessary. Again, it was sort of a theory. I don't have the proper length bolts to attach the tube, but basically I have enough threads now going. That's basically the amount of thread going through that little insert. But considering the fact it just holds this breather tube that vents crankcase vapors down to a canister down, well, okay, lower on the engine, that goes in there, a couple bolts hold it in place. Basically, this little job here saved the guy about, well, a few $100 anyway. So that's all I really needed to do. Just going to break this setup down, and, well, yeah, it looks dumb. It's, the use of OSB is probably not in the machinery's handbook, but it did what I needed to do. So this will work a little bit better. It would, I wonder how much it would have cost Volvo to put a couple studs in there instead of bolts. And then you can see on the top there, I just put a little bit of silicone to seal off the tops of those bars. Hopefully we won't get any water intrusion there again. And even then we have nuts on there now, so this will work just fine. Like I say, that little tube runs down the side of the engine into a catch can there to separate out the oil vapors and such. In the end, we're going to be able to put this thing back together and reuse it. So I I call it a qualified success, not necessarily a blazing success, but I'll call it a qualified success. So otherwise, one way or another, I hope you found it interesting, even with all the shortcomings. But for what it's worth, I just want to say thanks to everybody who still wants to come hang out with me in my garage. Thanks to everybody who subscribed. I do appreciate it if you do. If you haven't, that's cool. Thanks for coming by. Good to see you. Thanks for all the comments and the likes and the emails from people who've wanted to get a hold of me and say hello. Like I say, a good half of the fun of this whole YouTube thing is just getting to know other people and getting ideas from people around the world. So otherwise, thanks again for everything, and I'll see you next time.